Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 6 video on the chapter of direct and inverse proportion, where I will solve the objective questions of exercise 12C from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are visiting my channel for the first time, and if you are liking my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of exercise 12C on the chapter of direct and inverse proportion. Okay, so I have written down all the questions of exercise 12C from the textbook of author RS Aggarwal. So these are all multiple choice questions. Each question has 4 choices and one choice is correct. Now, for this video, for solving these questions, I have now written down all the formulas and the concepts that will be used to solve the problems. But please do so whenever you solve a set of problems of any chapter. Always go through the concepts and formulas that you have used to solve the problems. This will provide a regular revise of the chapter concepts, and it will stay for a longer time in your memory. Always do that. Okay, so let's start solving the problems. The first problem says that if 14 kg of pulses cost rupees 882, what is the cost of 22 kg pulses? So this is an example of articles and cost. We know that if the cost of articles is constant, we know that. So for constant, for if the constant for constant article price, that is price of cost of one article, for constant article price, we know that if we consider x as the, in this problem, the amount of so it is not articles, actually it is for constant article, this is about pulses, this is about amount of pulses. So for constant article price, uh, instead of constant article price, I think the better way of saying will be for constant uh, item price, or for constant rate of price, that is in this case rate of cost of pulse per kg. So for constant rate of pulses, we know that the amount of pulse, the amount of pulse, the amount of pulses in kg, and the quantity y, which we can say the cost of pulses in rupees. These are these are directly proportional to each other, that is x and y varies directly with each other, or we can say that x varies directly with y. So where x is the amount of pulses in kg, y is the cost of pulses for a given amount of pulses, where we should keep in mind that these two quantity x and y will vary directly with each other only when the rate of the pulses is constant, that is 1 kg of pulse, the cost of 1 kg of pulse is kept constant. So now we can quickly create the table based on the given data or information. It is saying that 14 kg of rice, 14 kg of rice costs 882. Okay, and now it is asking what is the cost of 22 kg of pulses. So let's say 22 kg of pulses costs rupees y1. So now since these two quantities x and y are varies directly with each other, we must have 14 by 882 should be equal to 22 by y1. So this implies y1 is equal to 22 multiplied by 882 by 14. So 211, 2 7 and 7 divides 882 with 1 2 6. So this is equal to, what is 126 multiplied by 11? 126, 126, 6 8 3 1. So this is rupees 1386. So the cost of 22 kg of pulses is rupees 1386, and hence the correct choice is D. D is the correct choice. Answer is choice D. Okay, let's do uh, problem number 2. If 8 oranges cost rupees 52, how many oranges can be bought for rupees 169? So the concept is same. We can say, if we consider X as the number of oranges, and Y as cost of oranges in rupees, then we can say that X will vary directly with Y when the cost of one orange is kept constant. That is, the cost of one orange is not changing, it is kept constant. Then we can say that the number of oranges is directly proportional to the cost of oranges. So now we can say, we can create the table of the quantity X and Y. It is given that 8 oranges cost rupees 52. So 852, and then it is asking how many oranges can be bought for rupees 169. So let's say X1 oranges can be bought for rupees 169. So we apply the formula for two quantities X and Y to be directly proportional, that is, the ratio will be constant. So X by Y is constant, so we will have 8 by 52 is equal to X1 by 169. This implies X1 is equal to 169 multiplied by 8 divided by 52. Now 4 divides 8 with 2, 4 divides 52 with 13, and 13 divides 169 with 13. So this is 26. So 26 oranges can be bought for rupees 169. Okay, so answer is C. Answer is choice C. Okay, let's do problem number 3. A machine fills 420 bottles in 3 hours. How many bottles will it fill in 5 hours? Okay, so a machine fills 420 bottles in 3 hours. How many bottles will it fill in 5 hours? So always try to, the first, so in solving problems in variation, the first task is to identify the quantities which need to be considered for the variation, that is X and Y. Now then the task is to figure it out, determine whether the quantity X and Y are varying inversely or directly, and then you create the table and find the unknown. So in this problem, the quantity we can see is time, that is 3 hours, and number of bottles, that is 420 bottles. Okay, so now if the number of bottles, now so a machine is filling 420 bottles in 3 hours. Now definitely the efficiency of the machine is constant, that is, the number of bottles that the machine can fill in 1 hour, that might be constant. So we can say for constant, you can say, you can consider machine, for constant machine efficiency, that is, by efficiency you can consider that the number of bottles that the machine can fill in per hour. So for constant machine efficiency, if you consider X as number of bottles filled, and Y as the time taken. time taken to fill the bottles. To fill the bottles. This you can, the unit of y you can consider as hour. So definitely, if there are now more number of bottles, the time taken will be more, because the efficiency of the machine is fixed. That is, the number of bottles it can fill in 1 hour is fixed. So if there are more bottles, time will be more. If there are less bottles, time will be less. So clearly, x is varying directly with y. Now if we create a table of x and y, it is given that 420 bottles is filled in 3 hours. Now it is asking how many bottles it will fill in 5 hours. Let's say x1 bottles will be filled in 5 hours. So now we must have 420 by 30 is equal to x1 by 5. So this implies x1 is equal to 420 multiplied by 5 divided by 3. This is 140. So this is 700. So 700 bottles will be filled in 5 hours. So the answer is choice B. Answer is choice B. Okay. Let's do problem number 4. A car is traveling at a uniform speed of 75 km per hour. How much distance will it cover in 20 minutes? Okay, so let's first identify what are the quantities involved. So, how much distance will it cover in 20 minutes? So, distance is a quantity. So, distance. Will it cover in 20 minutes? So, time. Time is a quantity, distance is a quantity. Now, it is asking in 20 minutes how much distance the car will travel. Now, it has given the fact that in 1 hour, the speed of the car is traveling at a uniform speed, of 75 km per hour. That is, it is given that in 1 hour the car is traveling 75 km. This fact is given. Now a car is traveling at a uniform speed of 75 km per hour. How much distance will it cover in 20 minutes? Okay. So now remember that when a car, so for car at uniform means constant, you can say uniform fixed, the speed is not changing, that is for car at uniform speed, if you consider the two quantities x as the distance covered, the unit, let's say in kilometer, and the quantity y as the time taken to cover the distance as in minutes. Since it is asking how much distance will it cover in 20 minutes, now you must be very careful in determining the units of x and y. So if you consider the unit of y as hour, then obviously you have to convert the 20 minutes into hour. And if you consider the quantity, if you consider the unit of y as minutes, then you can obviously do the calculation based on minutes. So I will consider the unit of y as hour. Now, okay, hour. Now, since the speed is constant, please remember that when the speed is constant, the distance covered is directly proportional to when the speed is constant, the distance covered is directly proportional to the time. So if the time is more, since the car is traveling at a constant speed, it will cover more distance. And if the distance is less, it will take less time to cover less distance, and it will take more time to cover a larger distance since the speed is constant. So we can say that x is varying directly with y, where x is the distance covered in kilometer and y is the time taken to cover the distance in hour. Remember that the car is traveling at a uniform speed, that is, the speed is constant. Now let's see what data we can enter in the table. So the first data we get from the fact that the car is traveling at uniform speed, that is, it is covering a distance of 75 km in 1 hour. So 75 and 1. And then it is asking how much distance will it cover in 20 minutes. Now let's say it will cover x1 distance, x1 kilometer in 20 minutes. Now this 20 minutes we have to convert as hour. So 20 minutes will be 20 by 60 hour, since we have assumed that the unit of y is hour. Okay, so now since x is varying directly with y, we must have 75 divided by 1 is equal to x1 divided by 22, not 22, 20 by 60. So this implies we are getting 75 is equal to on the right hand side. If you simplify right hand side, it will become 60 in multiplied by x1 divided by 20, which is 3x1. So this implies x1 is equal to 25 kilometer. 25 kilometer. So the correct choice is A. Now, as always, whenever you solve an unknown in a problem of variation, always verify that your answer is consistent with the type of variation. So if the quantities involved are varying directly, then accordingly check that the quantity you have solved, it is as per the concept of direct variation. And if the quantities are varying inversely, then also check that your answer is as per the variation, that is inverse variation. Always always check this after you calculate the answer. Okay. Now my solution and my problems are really overlapping. I'm really sorry for this, but I hope you can make it out. So let's solve problem number 5. The weight of 12 sheets of thick paper is 40 grams. How many sheets would weigh 1 kg? Okay, so definitely the thickness of each paper is fixed, it is not changing. So then we can say for same thickness for, or rather for paper of same thickness, all the paper considered are of same thickness. So for paper of same thickness, if we consider the two quantities x as, not paper actually, sorry, sheets, for sheets, so all the sheets are of same thickness. So x, let's consider the quantity x as the number of sheets, and the quantity y as the weight of the sheets, in grams. Now definitely, if the thickness of each paper, that is the weight of each paper of each sheet, is same, if the it is considered, if you consider the thickness of each sheet to be the same, that is, by thickness you can also consider the weight of each sheet is same, then if you increase the number of sheets, the total weight will increase, and if you decrease the number of sheets, the total weight will decrease. So clearly we can see that x is varying directly with y. Now if you tabulate some data, x, y, it is given 12 sheets, the weight of 12 sheets is 40 grams. It is asking how many sheets would weigh 1 kg. Now 1 kg, we have considered the weight of the sheets in grams. So while entering the value of 1 kg in the table, you have to convert 1 kg as grams, which is 1000 grams. 1000. Let us assume that x1 sheets will weigh 1 kg. So we have this table. Now Using the concept that x and y are varying directly with each other, we can say 12 by 40. My machine is running slow. I can't write it properly. Anyway, for 12 by 40 is equal to x1 by 1000. This implies x1 is equal to 1000 multiplied by 12 divided by 40. So this is equal to 300 and 300. So 300 sheets will, the weight of 300 sheets will be 1 kg. So the answer is choice C. Okay, let's do problem number 6. A pole 15-meter high casts a shadow of 10 meter. At the same time, what will be the height of a tree, the length of whose shadow is 7 meters? So this is a very classical problem where the concept is that at a specific time, now, or you can say at a specific time or at a specific position of the sun, the ratio of any object which has a height, the ratio of the height of any object and the length of its shadow casted by the sun, this ratio is same for any object at that specific time. So if we consider a tree or a pole, the ratio of the height of the pole and its and the length of its shadow will be equal to the ratio of the height of a tree and the length of the shadow of the tree at a specific time. So this is the concept. So at a specific, you can say at a specific time, if you consider x as the height of an object, let's say in meter, and y to be the length of its shadow, this is also in meters. These two quantity will be varying directly with each other. The more is the height of the object, the longer will be the length of its shadow. And this constant, as you know that when two quantities x and y varies directly, their ratio is a constant. So the ratio is a constant, and this constant will be different for different time. Say let's say at 10 o'clock in the morning, if you take the ratio, if you calculate the ratio of the height of any object and its the length of its shadow, this ratio will be same for any objects at that specific time. Now at some other time, let's say 2 p.m. or 12 o'clock in the noon, this ratio, the ratio will be same for all the objects, but the constant will be different from the constant that you will calculate at that you have calculated at 10 a.m. So the ratio of constant or the constant of proportion or variation for this problem will be different at different time. Okay. So now let's say create the table. It is given that a pole of 14 meter high casts a shadow of 10 meter. So 14 and 10. And then at the same time, what will be the height of a tree? So let's say the height of the tree is x1 meter. And it is given that what will be the height of a tree, the length of whose shadow is 7 meters. So we have 7. So now we can say 14 by 10 is equal to x1 by 7. So this implies x1 is equal to 14 multiplied by 7 divided by 10, which is equal to 98 by 10, which is equal to 9.8 meter. 9.8 meter. So the answer is choice B. Answer is choice B. Okay. Question number 7. A photograph of a bacteria enlarged 50,000 times attains a length of 5 centimeter. the actual length of bacteria is, okay, so this is a new kind of problem I'm facing for the first time. The concept is little, I mean, the concept is same. It is either the quantities will be either varying directly or inversely, but it sometimes it becomes hard to identify the quantities and how they are related. Either they are related directly or inversely. So we can see that what are the quantities? The actual length of bacteria is, okay. So the one quantity is the actual length of the bacteria. Actual length of the bacteria. What is the other quantity? A photograph of a bacteria enlarged 50,000 times attains a length of 5 centimeter. The actual length of bacteria is, okay. A photograph of a bacteria. Okay. So 5 centimeter is the enlarged version, and we have to find the uh, actual length of the bacteria. Now, uh, in a photograph of a bacteria enlarged 50,000 times. So there is a photograph, and in the photograph there is the in the photograph the photograph contains the actual length of the bacteria. Bacteria is very small. So when that photograph is enlarged 50,000 times, the length is becoming 5 centimeter. Okay. So this is a kind of map. We did a problem on map where let's say 2 centimeter, a distance of 2 centimeter between two cities in the map could be 10 kilometer, apart. So the if two cities in a map are 2 centimeter apart in the map, then the actual distance of those two cities could be 10 kilometer or 100 kilometer. The concept is like that. So let's identify the quantities. Let's say x is x is, let's say, actual uh, x is the actual length of bacteria. 100 times. Now, what could be y? Y could be the enlarged. The y could be uh, a photograph of a bacteria enlarged 50,000 times. So if so basically so the quantities are the actual length of the bacteria and the enlarged in length of enlarged uh, a photograph. Actual length of bacteria in photograph, let's say, in photograph, and y to be the in a length of enlarged length of uh, photograph of bacteria enlarged 50,000 times. Enlarged 50,000 times attains a length of 5 centimeter. So the So the enlargement, that is the enlarging factor, is same. The enlarging factor is the same, which is 1 is to 50,000. So basically, this problem is based on the fact that uh, a photograph a photograph being enlarged by 50,000 times. That is, it is a scaling. That is the scaling of the photograph. So a photograph being enlarged by 50,000 times. So the quantity can be x, actual length of bacteria in photograph, and length of enlarged bacteria, length of enlarged uh, length of bacteria in enlarged enlarged photograph. So a photograph of a bacteria is taken, then it is being enlarged 50,000 times. So let's consider the quantities: x to be the actual length of bacteria in the photograph, and y to be the length of bacteria which has been enlarged 50,000 times. So definitely x will vary directly as y, because if the actual length of bacteria is more, then after enlarging it 50,000 times, the length of the enlarged bacteria will obviously be more. Now let's try to create the table of xy. Now obviously these two x and y are in, so these two, this is in centimeter. The units of both x and y are centimeter. So a photograph of a bacteria enlarged 50,000 times. So this is a hidden fact. This is a hidden data, which means that if the actual length of bacteria in the photograph is 1 centimeter, then the length of the bacteria in the enlarged photo will be 50,000 centimeter. So this is the main concept that you must understand. This is one data that it has given in the form of by saying that a photograph of a bacteria enlarged 50,000 times. Now, the second data we can consider is that it is asking the actual length of bacteria is. So, what will be the actual length of bacteria when the after the photo has been enlarged? Its length is 5 centimeters. So this is 5, and let's say the actual length of the bacteria is x1. So we must have 1 by 50,000 is equal to x1 by 5. So this implies x1 is equal to 5. I really do not have any space. 5 by 50,000. So this is 5 by 50,000. Now, where will I write? Okay, so let's do it here. So we are having then x1 is equal to 5 by 50,000. So this is equal to 1 by 10,000 centimeter, which is equal to this is how many? Okay, so this is 10 to the power minus 4 centimeter. So the actual length of the bacteria is 10 to the power minus 4 centimeter. So the correct choice is C. C is the correct choice. Okay, let's do the next problem. 6 pipes fill a tank in 120 minutes. Then 5 pipes will fill it in how many minutes? So this problem we have already done previously. So this is about for pipe. Now the size of all the pipes are same. For pipe of same size, uh, for pipe of same size, the quantities x, let's say the quantity x be number of pipes, and also the volume of the tank is constant. That is, a constant amount of water is being filled. So x is the number of pipes, and let's say y p the time taken to fill the tank by the pipes, time taken to fill the tank. Remember that the volume of the tank is constant, it is not changing, and also the pipes are all of same size. When this is the fact, then we can say that the number of pipes will be inversely proportional to the time taken, because the more the number of pipes, they will fill the tank, the same amount of tank in less amount of time. So time taken to fill the tank, let's say this be in minutes, since all the data of time is given in minutes. So clearly we have x is varying inversely with y, that is, more the number of pipes is, less time it will take to fill the same amount of tank, that is the volume of the tank is same. So now if we create the table of x and y, it is given 6 pipes fill a tank in 120 minutes. So 6, 120, and then it is asking then 5 pipes will fill it in. So let's say 5 pipes will fill the tank in y1 minutes. So we have this table. So since x and y are varying inversely with each other, their product will be a constant. So we can say 6 multiplied by 120 will be equal to 5 multiplied by y1. So this implies y1 is equal to 6 multiplied by 120 divided by 5. So this is 24, and this is 144. So 144 minutes. Okay. So the answer is 144 minutes, and hence the correct choice is B. B is the correct choice. Okay, let's do the next problem. 3 persons can build a wall in 4 days, then 4 persons can build it in. So this is about work and time. Now remember that over here the amount of work is constant for and the constant work is for building for constant amount of work, which in this example is to build a wall. The wall is same. You can consider the amount of work to be the height of the wall or the length of the wall. So the height of the wall or the length of the wall being constructed is same. So this implies that the amount of work is same. So for constant amount of work, if we consider x to be a number of persons to build the wall, that is number of persons required to build the wall, and y is number of days to build the wall, number of days required to build the wall, then obviously we can say that x is varying inversely with y, because to build the same wall, more persons will build it in less number of days, and less persons will take more time. So the quantity x and y will be varying inversely with each other. So now let's create the table. It is given 3 persons can build the wall in 4 days. So 3 and 4. It is asking then 4 persons can build it in. So let's say 4. So let's say 4 persons will build the wall in y1 days. So now let's have some space. Okay, so uh, since x and y, the data x and y, quantity x and y are varying inversely with each other, their product will be a constant. So we can say from this table that 3 multiplied by 4 is equal to 4 multiplied by y1. So this clearly says that y1 is equal to 3. So 4 persons will build the wall in 3 days, and the answer is choice B. Okay, let's do the last problem. I think this is the last problem. Okay, problem number 10. A car takes 2 hours to reach a destination by traveling at 60 km per hour. Okay, how long will it take while traveling at 80 km per hour? So this is about distance, speed and time. So the concept is that when in this problem the distance is kept constant, the distance is fixed, that is, it is asking if the car takes 2 hours to reach a destination by traveling at 60 km per hour, how long will it take while traveling at 80 km per hour, that is to travel the same distance. So for constant distance covered, for constant distance covered by any vehicle, in this problem it is car, for constant distance covered, if we consider the two quantities x as the speed of car, in this problem it is given car, so I am writing speed of car and the speed is in kilometer per hour, and y to be the time taken to cover the distance, that is the constant distance. This is in hour. So if the distance being covered is same, then the quantity x and y will vary inversely with each other, because if the speed of the car is more, then it will take less time to cover the same distance, and if the speed is less, then it will take more time to cover the same distance, and if the speed is more, it will take less time to cover the same distance. So clearly the quantities x and y are inversely proportional to each other. Now let's create the table x and y. So it is given that the car is traveling at 60 km per hour and it takes 2 hours. So 60 and 2. Now it is asking how long will it take while traveling at 80 km per hour. Let's say we assume the car will take y1 hours to cover the same distance when it is traveling at a speed of 80 km per hour. So now we will have 60 multiplied by 2 should be equal to 80 multiplied by y1. So this implies y1 is equal to 60 multiplied by 2 divided by 8. This cancels this, 2, 4, 3, 2. So this is 3 by 2 hour. So the car will take 3 by 3. The car will take 3 by 2 hours to travel to cover the same distance or to reach the same destination. At a speed of 80 km per hour. Now we have to convert the 3 by 2 hour as hours and minutes. Now 3 by 2 hours is equal to 1 and 1 by 1.5 hours. So this is equal to 1 plus half hours. So this is equal to 1 hour plus half hours. This is equal to 1 hour plus half multiplied by 60 minutes, which is equal to 1 hour 30 minutes. So the car will take 1 hour 30 minutes to reach the same distance or to cover the same distance traveling at a speed of 80 km per hour. So the Answer is choice A. So this brings to an end in solving the exercise problems of multiple choice problems of exercise 12C from the textbook of author RS Aggarwal. Even though these questions were straightforward, you should solve always the MCQ problems of all chapter as and when you complete them, and also after this video I will solve the test paper 12. Now the problems of test paper are relatively a bit harder than the rest of the problems. So please stay tuned for the next video, which will be solving the test paper 12. Once I complete that video, I will then create a homework number 2, which will be based on the entire chapter of direct and inverse variation. So the next video will be on the test paper 2, solving test paper 2, and then after that the video will be solving homework problems number 2. And then also I will start parallelly solving 10 good problems in the other playlist, Maths 8 Hot. Now the 10 good problems will be quite harder from the problems that I have solved in this playlist, that is CBSE Maths 8 RS Aggarwal. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.